So hello everyone. So last time we starting for section 3.2, and this section talking about the polynomial function. So we starting for the polynomial function. I define the polynomial function, and so the polynomial function is a function look like this: p of x equal an x to the n plus an minus 1 x to the n minus 1 plus to the a1 x plus a0. And I give the definition for the constant a0. So a0 is calling, this one is calling the constant term, or also is called in the same time the constant coefficient. And an here from last time is called the leading coefficients, and the term anxn is called the leading term, and an and an minus 1, and all these are calling coefficients. Okay, this is just review. And also I starting for graphing the basic polynomial function. I talk about the polynomial function look like this: p of x equal x to the n, and I draw when n equal, for example, 1. It's like a line. It will be like, the function will be like x, p of x equal x. When n equal 2, this one is a line here. P of x equal x is a line, and when n equal 2, so b of x equal x squared, it's like parabola. And when n equal 3, p of x equal x to the power 3, it's look like that. This is parabola here. This is look like line. Okay, and I talk when also I said when the n is even, so all the graph, it will be like look like these things. But when n is odd, most of the graph, it is look like this. Okay, so here when n is odd, here when n is even, here when n is even. Okay. Then I give some like example for graphing. By using these things, I start graphing for polynomial has a power like n is large, like n equal, for example, 5, n equal 6. And I use the transformation method for these graphs. Okay. Then I move to the end behavior. I give you 4 cases for the end behavior. I said the end behavior determined by the end behavior. The end behavior, it's determined by 1, the degree of the polynomial n, the polynomial p of x, and also it depends on the sign of the leading coefficient an. So it depends on the degree. What's the degree for this polynomial? If an not equal 0, the degree will be n, okay? But also the sign, it depends in the coefficient an. So again, it depends in the coefficient an, if it's positive or negative. I give 4 cases for the end behavior when B has odd degree and the leading coefficient is positive or the leading coefficient is negative. And I give when B is even degree like 2, 4, 6, 8, all these numbers are even. So what's happened to the end behavior when the leading coefficient is positive or the leading coefficient is negative? So go back again to the last class and review the 4 cases. The last things I left it from the last time is how to graph the polynomial function by using the zero. The zeros for the polynomial function. Any questions so far for these things before we go to the new topic in this section? Perfect. Anyone has a question? Okay, good. So now let's go to the new things in this section is called using zero zeros to graph polynomial function. So first things before I start the things, I have to give you some properties is called if I have function is a polynomial function, if B is polynomial function, and this polynomial function, and also I defined another thing, C is a real number, So I define 2 things. B is a polynomial function and C is a real number. The real number, again, it's the negative, like -5, -6. The natural number, the integer number, and the rational numbers and irrational numbers. All these is real numbers. Then, okay, so then the following are equivalent. Are equivalent. So first things, all these nodes are equivalent. C is 0, is a 0 of the polynomial B. 2, that's mean x equal C is the solution of B of x, or in different word, I can say B of this element C is equal 0. So since C is a 0 of B, that's mean B of C equals 0. No, you don't have to send me the quiz. No, this quiz just for you, just to solve it and keep it for you. And I will send you another quiz maybe today. This quiz is not for grading. You don't have to send it back to me. Okay. Third things, x minus this real number C is factor of the polynomial is a factor of b of x. Fourth thing, c is x-intercept. Why c is x-intercept? Because when I plug c, because when I plug c, they give me 0. That's mean p of x, that's y, like 4 from section, I think, in chapter 2 equals 0. So we setting y equals 0. So that's mean x-intercept. So the 1 and 2 and 3 and 4 and 5, no, it's until 4, I mean, 1, 2, 3, 4, all of them are equivalent to each other. That's mean c is 0 of the polynomial b. That's mean p of c equals 0. That's mean x minus c is a factor for the polynomial b of x. That's mean c is x-intercept of here of b of x. This is the first properties. Second things, second thing, I'm talking about how to find the 0 for the polynomial. Now, how to find the 0 for the polynomial b of x. We have two steps. First things, you have to know how to factor the polynomial. You have to factor the polynomial. After you factor the polynomial, you have to make b of x the polynomial equal 0. It's called use the zero product properties. Using zero product properties. That's mean make b of x equals 0, then find the zeros for the, like solve the function or solve the polynomial function. Any questions so far for these things before I move to the next slide? Okay, perfect. So now let's give example for how to find the 0 for b of x. So for example, if I have, for example, function, the polynomial function look like this, b of x equal x squared plus x plus 6. The question is, find the 0 for this function, or find the 0 for this polynomial function. Find the 0 for p of x. So first things, we have to factor p of x. So what's the factor for p of x is, what is it? X. We're looking for two numbers such that the multiplication is 6 and the distribute, like the two number, the distribution is 6 and where the subtract is 1. So the two number are plus 3 minus 2. Yes, Jose, that's true. So plus 3 minus 2. So we make this one. Now, second step, b of x equals 0. That's mean x plus 3 equal minus 2, x minus 2 are equal 0. So how we solve this polynomial function? How we solve it to find the 0 for the polynomial function? By making x plus 3 equal 0. That's mean x equal minus 3 and x minus 2 equals 0. So x equal 2. Yes, that's true. So here the function is minus 6. Okay, hold on. Something wrong. Here is minus 6. X squared plus 6 plus x minus 6. We're looking for two numbers. The multiplication is minus 6. The summation for this two number are 1. So the first 0 is x equal 2. Second 0 is x equal minus 3. Any question? Thank you, Roland. Thank you, Taylor. Any questions so far? Like this, we can find the 0 for the polynomial function. So now, okay, so now by using the 0 for the polynomial function, we can graph the polynomial function. So we can graph the polynomial function by using the zeros. So now I give you example how to graph the polynomial function. Okay, so let's go to the next slide. So example, graph the polynomial function p of x equal, I give you a simple one right now, easy one, then I start for the harder one. X plus 3, x minus 1, x minus 3, minus 3. So the question is now, what is the 0 for this polynomial function? Since this polynomial function is factored already, okay? It's already factored. Now we have to find the 0 for this polynomial. What's the 0? Minus 3, 1, and 3. That's true. So we make p of x, it's factored already, equals 0. That's mean equal x plus 3, x minus 1, x minus 3. So x equal 3, x equal 1, x equal here minus 3, sorry. X equal minus 3, x equal 1, x equal 3. This is the 3 zeros for this polynomial function. This is the first step. Now, second step, we graph a line. We find the sign for between these zeros and in the left and right side of these zeros. So we draw a line like that. We put in this line the zeros number, it's 1. here is the 3, here is minus 3. Okay, then we try to find uh, like the sign here is positive or negative, the sign here and the sign here and here also. So how we can find the sign here? By taking any element, any number between this interval 1 and 3, and then we plug it inside p of x. Same things here. And also the same things for this interval from minus infinity to the minus 3, and the same things for this interval from 3 to infinity. So let me like pick a number 2 here. Let me take here the number 0, and here let me take minus 5 for example, and let me take here for example 5 or 6 or whatever, any number. Okay, so now at 0 we have to plug it. B of 0 will give me 0 plus 3, 0 minus 1, 0 minus 3, and the answer is 3 times minus 1 times minus 3. The answer is 9. So it's positive. So the sign will be positive. No, not in this side, sorry. In this one, here. Here, it's positive here. So from minus 3 to the 1 is positive. Now we're taking b of 2, we do the same things. So it will be like negative. So the answer, I don't have to plug it, just plug it by yourself, but I will show you for 2. So 2 plus 3 is 5, and 2 minus 1 is 1, and 2 minus 3 is minus 1. So the answer is negative. So here the sign is negative. And for any number greater than 3 will be positive, just the 5 inside the polynomial. Any number is less than minus 3 to be negative. Just plug any number uh, less than minus 3. So I get the sign. It's negative, 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 negative here, then positive, then negative, then positive. So now how we can graph it? We draw a Cartesian plane and we put the zeros number in the x-axis of the Cartesian plane. So here is 3, here is 1, here is minus 3. Okay. Now the time for drawing. So any number greater than 3 is positive. That means the graph will be look like this. Any number between 1 and 3 is negative. That means the graph will be behind the x-axis. Any number between minus 3 and 1 is positive. That means the graph will be upward of the x-axis. Then any number less than minus 3 is negative. That means the graph will be less than minus 3. So this is the graph for the function b of x. Any questions so far? Is it clear? Okay, can I move to the next slide? Okay. So now let's give another example for this one, but now the example is not, the polynomial is not factor already. We have to factor it, find the
I have a
zero.
question, sorry.
Yes, what's your question?
I wrote in the chat box, when given 3 parts to solve, the graph will always look like this, right? The one that you just
We,
drew.
yeah, this one is look like this. The b
So
of x.
that's when we're given like 3 parts, like x plus 3, x minus 1, x minus 3.
No, this is in this example. This is for, like, you have to find, like I said, the zeros for this polynomial. First things, it's -3, 1, and 3. Then from these zeros, I can draw this polynomial.
Okay, so it doesn't matter how many
It doesn't matter.
Oh, okay.
Maybe some polynomials, they have like more than 3 zeros, like infinity, for example, 5, 7, 8. Just
Oh,
you have to check what's the sign, positive or negative, and what is the zeros for this polynomial. Two things you have to find: the
oh, okay.
zeros and the sign. The sign by choosing element between the interval like this, and you plug it inside the polynomial. So you check the sign is positive or negative. Is it clear?
Yes, thank you.
Okay, thanks. Okay, let's go to the next slide. I give another example, but most of the example is like 3 zeros or 4 zeros, no more than 4 zeros. Most of the example and the question in the exam. Okay, so let's b of x equal x to the power 3 minus 2x square minus 3x. The question is, find the zeros for b. Second question is b, graph b of x. So again, so how we can find the zero? First things, we have to factor. What's the factor for b of x? Is x times x squared minus 2x minus 3. Then we have to factor this again. So we have to factor this one again. So again, the whole factor for this polynomial is x times, we're looking for two numbers, the multiplication is -3, and the sum for these two numbers are -2. What is the number? Is -3 and x plus 1. Right. So now we can factor p of x. Second things, we can factor it. P of x equals 0. That's mean equal x minus 3, x plus 1. So the 0 are x equal 0, or x equal 3, or x equal -1. This is the 3 zeros for this polynomial function. This one, or this one, or this one. Now, second things, graph the polynomial. like before exactly. We get the 3 zeros, we draw a line, we put the zeros element in this line, so it's 3 and 0 and -1. Now we check the sign. We take any element here, any element here, any element here, any element here, then we plug all these elements inside b of x, this function here, b of x equal. So for example, if I want to take the 1 here I want to take the 1, here I want to take, for example, the -half, here I will take, for example, 6 or 7 or any number, here I'll take -5. So check by yourself, here from 0 to 3, from 0 to the 3, the sign will be negative. This is exercise, check it by yourself. Just plug the 1 inside b of x, they give you negative sign. Between -1 and 0 will be positive. Again, check it by yourself. Just plug b of -half inside the polynomial, they give you a positive sign. Also, for any number is greater than 3, they give me, hold on 1 second. Here it's different. Here minus, here positive. Here is, I'm sorry, between 0 and 3 is negative, and -1 and 0 is positive. It was like that, I think, positive. Then the function again here is positive. If I plug any number is greater than 3, any number is less than 1 is negative. Just plug the number, these numbers, inside the polynomial, this polynomial function. Any question in this slide before we moving to the next slide?
Professor.
Yes.
Okay, so how do you decide according to which number according to which bigger number, like for here, any number bigger than 3 is positive. So how do you decide that the number will be 3?
How I decide the number is 3? It's the zeros. Look to the 0. We just put the zeros in the line. This is 0, the 0 number. The -1 is the 0 for the polynomial. Look, this is the 0 for the polynomial. Here, this one is the 0 for the polynomial. The 0 is the 0 for this polynomial, and the 3 is the 0 for the polynomial. Just I put it in the line. Is it clear? The -1 is the 0 for the polynomial. Is the 0 for the polynomial. The 0 is the 0 for the polynomial. The 3 is the 0 for the polynomial. Just I arrange them. -1, 0, 3. It makes sense?
Yeah.
Okay.
Thank you.
So you're welcome. So now, after you put the zeros, you pick any number is greater than 3, like 5, 10, 100, 1,000, whatever. The answer always positive. Any number between 0 and 3, the answer is always negative. Here always positive, here always negative. Any question? So now let's starting graphing for this function. So here the -1 again, the zeros element, here the 0, and here is the 3. So again, greater than 3 is positive. Between 0, between 0 and 3 is negative. That's mean down. Between -1 and 0 is positive, so up. And between and less than -1 is negative, so down. This is the graph for the polynomial function b of x. So the important things you have to show on the graph the zeros element 3, 0, and -1. Any question? Okay, so let's go to the. So we finished this section by finding the zero and the graph the polynomial function. So let's go to the new things, to the new chapter 4.1. This chapter is about the exponential function. Exponential function. So what's the exponential function? So we learned the polynomial function. We know what is the polynomial function. Now we will learn different kind of function. It's called exponential function. So the exponential function look like function like that. Looks like a function. Look like a function like that. It's like f of x, for example, equal to the number, like real number. This real number is positive and greater than, positive greater than, that's meaning greater than 0. So I choose 2, the number. So this function, it is exponential function. Second things we have to learn from the beginning of this section, this function is increasing fast or quickly. Is different about the polynomial function. That means, like when I plug a small number inside this function, for example, f of 3 is equal to the 3. And this is equal 8. For a small number, they give me like big number. 8. Now for f of, for example, 10, small number, give me like big number, 10, 24, 1024. And for example, f of 30, give me 2 to the 30, and this number equal 1 million or 1 something, 0, 7, 3, 7, 4, 1, 8, 2, 4, and so on. This means this function is increasing quickly. This good properties for this function, increasing quickly. Different about the polynomial function. The polynomial function, for example, if I want to take f of x equal g of x equal x squared, g of x equal x squared, this function is not increasing quickly. Like if I want to take g of 2, they give me 4. G of 10, they give me 100. But look here, g of 10 is 1000. 1024 is so large number, but g of 10 is 100. That means the function, the polynomial function, is not increasing quickly. So this is like introduction for this section. Now let me define what is the mean of exponential function. What does that mean? So the exponential function definition. Exponential function with base a is the function of x equal a to the x. This is exponential function such that x is belong to the real number and a is greater than 0 and a not equal to the 1. Why do you think a is not equal to 1? Why a is not equal to 1? Who would give me the answer why a is not equal to 1? Why the exponential function, this function, here a, this a is not equal to 1, is not equal 1, why? This is good, it's not increasing, but no, it's still increasing, but not, no, it's not increasing, right? But can you give me like, explain why more? Because it's not because linear, no. Because if, for example, if a here is 1, so f of x will be like 1 to the x, and 1 to the x is equal 1. Like if I plug any number to the, like if I plug any number in this function, always give me 1. And the 1 is not exponential function, is not exponential function. That's why the 1 is not, a is not equal to 1. So f of x equal 1 is constant function. It is constant function. Okay? Will not be exponential function, will called constant function. Okay. Any question before we move to next slide? All right. So again, y greater than 0. So yeah, y greater than 0. Who know the answer? It's nice question. Why a like supposed to be greater than 0? Who will give me the answer? Why he is not like for any a, for any r in r, any a in r? Okay, I will answer why. Because if the function look like f of x equal a to the x, right? And like I said, if a, for example, negative, like a belong to r, so it will be like, look like, for example, minus a, right? Minus a. And the minus a to the x, it's the same like the function a to the x, but reflected. This function is reflected around the x-axis. Okay, this is the difference. That's why I don't need to reflect the function. I need it just to be like only the positive things. So the function, this one, if here, if a, for example, less than 0, it will be like, look like minus a to the x. Okay, and here a is positive. That's mean the function look like minus the function, minus the original function. That's mean it's reflected around the x-axis. I will explain more during the next example for these things. So let me give you example first. Suppose my function f of x is example for like exponential function. F of x equal 2 to the x. Or for example, g of x equal 3 to the x. Or h of x, for example, equal 7 to the x. All these are called exponential function, such that this is called basis, the base. And this, the number 3 is called base. Number 7 only is called base. So the 3 is base and the 2 is base. Okay. This is all these f of x, g of x, h of x are example for exponential function. Okay, so now next example, evaluate the function for the following. Suppose I have function f of x equal 3 to the x. The question is find f of 5, f of pi, f of square root of 2. Okay, what's the answer for the first one? F of 5. Where is f of 5 here? Just you have to plug the 5 inside this function here. So when you plug the 5 inside this function here, f of 5 equal 3 to the 5. Now second one, what is f of pi? It's 243. Thank you. But in the exam, we don't have to use the calculator, so you can keep the answer like that, 3 to the 5. But thank you. So what's f of pi? Just you plug the pi inside the function, and we get 3 to the pi. Third one, where is f of square root of 2? F of square root of 2 is equal to 3 to the square root of 2. Just you have to know how to evaluate the function. Any question? Okay, so now let's go to the next topic, how to graph the exponential function. Graph the exponential function. So like usual, for example, I give example, graph the function f of x equal 3 to the x. And the second example, this is A. B, graph the function g of x equal 1 over 3x. Like usual, we're starting graphing the function by using the plotting points. choosing by using the table. X, this is the first things. Then we learn how to do the transformation for the function. So x, and here f of x, and here g of x. So we'll choose numbers, like for example, I will choose 0, 1, 2, 3, minus 1, minus 2. Just you have to plug the element of x inside the function f of x and g of x. Then we have to graph the function. So what's f of 0? What is f of 0 here? We start from the 0. We plug the 0 inside the function f of x. So f of 0 is equal 3 to the 0 is 1. Yes. So 1. Now, what is g of 0? You plug the 0 inside the g of x. So 1 over 3, everything to the 0 is again 1. For the number 1, what is f of 1? Is it 3 to the 1? Is 3. What is f of 2? What is f of 2? You plug the 2 inside the function f of x. So 3 to the 2 is 9. And 3. What is f of 3? 27. And the same things for the minus. What is f of minus 1? Is 3 to the minus 1 is equal 1 to the 9. Okay? And for minus 2 is 3 to the minus 2. And the answer is, sorry, 1 to the 3 here. Here, 1 to the 3. The minus 2 is 1 to the 9. Because it will be like 1 over 3 square. 1 over 9. Now for the function g of x, what is g of 1? You plug the 1 inside the function g of x. So give me 1 over 3, everything to the 1. So 1 over 3. What is g of 2? Is 1 over 9. What is g of 3? Is 1 over 27. Now again, what is g of minus 1? You plug the 1 inside the function here. So it give me 3. Why? Because 1 over 3 to the minus 1. Let me explain more. 1 over 3 to the minus 1. This give me 1 to the minus 1, 3 to the minus 1, give me 3 over 1, give me 3. And what's about the minus 2? It's 9. Again, the same things. We plug the minus 2 inside the function g of x. And again, the 0 is 1. Any question? So again, how we can graph this function? By using the points. For the function f of x, we're starting graphing this function f of x here. So at 0 is 1. This one at 0 is 1. At 1 is a 3. Here is a 3, for example. Here 1. At 2 is 9. This is 9. At 3 is 27. So this is, for example, 27. And again, for minus 1 is 1 over 3, like small number. At -2, it's 1/9 is less than 1/3, and so on. So the function look like this. The graph, it's look like this. So this is the function f of x. Okay. Now the graphing of the function g of x, the same things. At 1, it's 1. At 0 is 1. So we're graphing this function here, g of x. This is by, I gave a blue color for the g of x. I give red color for the f of x. At 0 is 1. 1 is 1/3, small number. At 2 is 1/9. And infinity is like 0, closing for 0. And the same things. The function look like that. At -1 is 3. So this is 3, for example. Let me graph it again. So it will be like that. So this is the g of x. So, but look here, the function, the red color, its reflection, like if we reflect it around the y-axis, it gives me the blue color, right? If we reflect the red color around the green line, the y-axis, they give me the blue color. That means there is a relation between f of x and g of x. What is the relation? So g of x is equal 1/3x, right? This is equal 3 to the -1, everything to the x. Now we multiply the -1 with the x. What does that give me? They give me 3 to the -x. And this is exactly f of -x. So the g of x and the f of x are equal, but like f of -x is equal to the g of x. So g of x equal to the f of -x. This is the relation between the two functions. That means if we want to graph the function f of x, if we want to graph this function f of -x, that means we have to reflect around the y-axis by the function g of x. Any question before we move to the next slide? Is it clear for all? So after we find that we know how to graph the function f of x equal x is equal 3 to the x, and the graph look like this. It is 1. So the question is, what's the domain for the function f of x, and what's the range also? What is the domain for f of x and the range too? What is the domain for the function f of x, and what's the range? Who will give me the answer? From the graph, just look into the graph and you can find the domain and the range. What is the domain and what is the range? No one will give me the answer? Yes. What does that mean? Taylor, she said the domain is from minus infinity to infinity. What does that mean from minus infinity to infinity? It's R, the real number. So if we look into the graph, to find the domain, it's like the value for the x-axis. So all the value for x-axis are used. So from minus infinity to the infinity, this is the domain, from minus infinity to the infinity. This is mean it's the R real number. So this is the domain. So the domain again, it's the possible input value. So we use all the possible input value. Now what's the range? The range is from 1 to Taylor, she said from 1 to infinity. This is not, it is not correct. Who will give me the range for this function from the graph?
Is it the same thing as, is it negative infinity, infinity again?
No, because we did not use the negative numbers. Look to the graph, which number we use. Yes, Miles, he's correct. So we're starting from the 0. Look to the minus number. It doesn't use. That's mean it's not from minus infinity to infinity. So from the graph, we can see that it's from the 0, but the 0 is not inside the range. That means it's open interval to the infinity. So the range is from 0, but is open because the graph to be like close to the x-axis here, but will not touch it, will not touch the x-axis. That means the 0 will be open interval to the infinity. Is it clear for all? Okay, so now I'll tell you something. The domain for all the exponential function look like this, is always the domain is R. And the range is from 0 to infinity. I mean, look like this. F of x mean equal a to the x such that a is greater than 0 and a is not equal to the 1 and x belong to the real number. Any function look like that, the domain always R, the range are always from 0 to infinity. This is always, but a must be greater than 0. So any question? Okay, let's go to the next slide. So again, and also the graph in general, I give you the rules for the graph. If my f of x look like that, f of x is equal a to the x and a again positive and a not equal when x is belong to the real number, then the graph it must be look like this. Look like that. If the a is greater than 1, if a between 0 and 1, it will be reflected around the x-axis. Go back to the example. If a between 0 and 1. And we know a is greater than 0, such that a is greater than 0 for both of them. So again, this is the rule for a graphing again. If a is greater than 1, the graph look like that. If a between 0 and 1, it's look like that. Going back to the example before, here. Look to the function f of x. A is 3 positive, is greater than 1. So it's look like this, the red one. But for the function u of x, the blue color, a here is 1/3, is between 0 and 1. So it's reflected around the y-axis. That's why it's look like that. So again, this is the general rule. Any question? Is it clear for all? Okay, let's go to new slide. Suppose I have function. Now, example. Suppose my function f of x equal a to the x, okay? And graph look like this. The graph, first one, look like that. And I know all the functions, the exponential passing the point 0 to 1, all of them. But this function, it passes again the point 2 and 25. The question is, find the exponential function f of x equal a to the x. So how can I find the function f of x equal to the a to the x? By using the graph. So from the graph, look to the graph. F of 2 is 25. F of this point 2 is 25. This the function is f of x. F of 2 is 25. From this point, I can find the exponential function. Since the exponential function, it's always look like f of x equal a to the x. So I plug the 2 inside this function. So f of 2 will give me 25. Okay. And also, before I start from f of 2, if I want to plug that 2 inside the function, this one here is a to the 2. A to the 2. And also it's giving the red one, f of 2 is 25. So make the f of 2 is a to the 2 and f of 2 is 25. That's mean from both of them, a to the 2 is equal 25. That's mean a is equal, what is a equal? 5. Why? Because 25 is 5 to the 2, such that both of them have the same power or exponent, so a equals 5. So now what's the function? The function look like f of x equal 5 to the x. So this is the function for this graph. Is it clear? I hope yes. Okay, perfect. Anyone has a question before we move to the next slide? Okay, let me give you exercise. You can do it by yourself. The question is, if I have a graph look like this, like that, and the point is a 3 and 1/8. The question is, find f of x so that equal a to the x. This is for you. You use the same step to find f of x equal a to the x. B, exercise. Okay, let's go to another example. Example 4. For example, I think 3. So the question is, graph each of the following by using transformation. So my given function, f of x equal 2 to the x. The question is now, first one, graph g of x that equal 1 plus 2x. Second one, graph by using the transformation. You don't have to use the plotting point. Equal minus 2 to the x. 3, find k of x equal 2 to the x minus 1. Okay, who will give me the answer, or how can I graph the first one? So before I graph the first one, I know how to graph f of x now equal f of x equal to the 2 to the x. The function look like this. This is exponential function. So by using this function, f of x equal 2 to the x, how we can graph the g of x? By using transformation. how we can graph the first one, g of x. No answer? So by using the f of x, I know how to graph the g of x. So g of x is like transformation for the function f of x. So here, the function g of x is equal 1 plus 2x. That means is equal to x plus 1, right? So we graph the function 2x, then we shift it up 1 unit. Is it clear? This is equal f of x because f of x is equal to the x plus 1. So we graph the function f of x, we graph the function f of x, we shift it up 1 unit. First one, is it clear? So the graph for g of x look like that. We shift it up 1 unit. So here instead of 1, 0, 0, 1, I mean, to be 0, 2. This point is 2. Then look like that. This is the function g of x. So we shift the function 1 unit, shift the original function f of x. Second one, who will give me the hint how we graph the h of x? This is transformation for the function f of x, but here we have minus in front. What does that mean? So I know h of x equal minus 2 to the x. This is equal minus f of x. Why? Because f of x is this function here, f of x is equal 2 to the x. So it would be like minus f of x. So we reflect it around the x-axis. We reflect the function f of x around the x-axis, so we get the function h of x. So the black color is the function here, the black one is the function f of x. Okay, so we try to reflect it around the x-axis. So the reflection for this function look like that. And they will give me the h of x. Now for the third one, who will give me the hint for the third one? How can I graph the third one? The k of x. This one. So again, k of x equal 2 to the power x minus 1. This is exactly equal f of x minus 1. Try to plug the x minus 1 inside the function f of x. They give me 2 to the power x minus 1. What does that mean? This means we shift the function f of x to the right 1 unit. For 3, we shift the original function f of x to the right 1 unit. So this is the function here. The black one is the f of x. We shifted 1 unit to the right. So it'll be like, look like that. And this is k of x. How is it equal to the f of x minus 1? I know the function. I know the function f of x here is equal to the x. Okay, so plug inside this function x minus 1. So f of x minus 1, this give me 2 to the x minus 1. But here look, k of x is giving, they ask me to graph this function. So k of x equal 2 to the x minus 1. And 2 to the x minus 1 is the same as the function f of x minus 1. Why? Because this one. So the function k of x is the same as the function f of x minus 1. And the function f of x is the black color, but we shifted to the right 1 unit because the one it's inside the function, inside the parentheses. Is it clear for all? Any question? Okay, so we finished this section 4.1. If you have any question before we move to the next section, you can ask. Anyone has a question? So we defined the exponential function. It's a function look like this. Okay, then we learn how to graph this function and how we evaluate this function for some elements. This is the 3 things important for this function, for this section. Any question? Okay, so let's go to the next section. If no one has a question. So the new one is 4.3. So we skip 4.2. It's called logarithmic function. Logarithmic function. So in 4.1, we start this chapter by the exponential function. Now we will learn the logarithmic function. So the exponential function and logarithm function, they have a relate or like a connection between this to this sections. So I know the function f of x, the exponential function. Let me start from the exponential function. What is the connection between the logarithm function and exponential function? So if you understand the exponential function, the logarithm function will be like easy. So again, the exponential function is f of x equal a to the x, such that a is greater than 0, a not equal to the 1, x belong to the R, real number. And we know how to graph this function. It's look like this. This is the graph for the function. If a is positive, if a is greater than 1, I mean. This function is 1 to 1. Why? The function of x is 1 to 1. Why is 1 to 1? Who would give me the answer? Why the function of x in the graph is 1 to 1? Because by using the horizontal line test. Thank you, Taylor. Yes, by using the horizontal line test. The horizontal line test, by drawing lines horizontal, this lines intersect the graph in just one point. This means the function is 1 to 1. And because the function is 1 to 1, that's mean the function has inverse. And the inverse for the function of x is the logarithm function. So this is the connection between the exponential function and logarithm function. The logarithm function is the inverse function for the exponential function, and vice versa. So the inverse for the logarithm is the exponential function, and the inverse for the logarithm function is the logarithm function. I mean, the exponential function is the logarithm function, log, the inverse for log is the exponential function. So that's mean if f of x equal y, so f of inverse of y equal x. This is the inverse. Okay. We have 10 minutes. So in this 10 minutes, I will like define what is the meaning of logarithm function, the definition, and I give you like small example. And next time we'll continue how to graph the logarithm function, and by using the plotting point and by using the transportation. So let's define the logarithm function. So the logarithm function the logarithmic function with base a is defined by log a to the x to the base a, and this is equal y. Okay, such that the log x to the base a equal y. This is mean a to the y is equal x. This y equal x. A to the y equal x. So this is exponential function, and this is logarithm function. This is from section 4.1, and this is this section 4.3. Logarithm function and exponential function are connected to each other. Any questions so far? This is the logarithm function definition. Log of x to the base a equal y, then a to the y equal x. Is it clear for all? So the logarithm function again is the inverse for the exponential function. 4.3 is the inverse for 4.1. And the same things. 4.1 is the inverse for 4.3. All right. So let me give you like some notes. This is called the logarithmic form, and here exponential form. So log x to the base a equal y, and here the exponential form is a to the y is equal x. And this is the same. A here is called base. A here is called base. Y here is called exponent. And y here is called exponent. Just definition, the names. Last things, let me give you example. Is it clear for all? Before I move to the next slide. This is the relation between the exponential and logarithm. Last things, last example. Clear. So the example is evaluate the logarithm. The log. So suppose, so the first one, what is the logarithm for 1000 to the base 10? B, what is the logarithm to 32 to the base 2? C, what is the logarithm for 4 to the base 16? What is the answer for the first one? What's log 1000 to the base 10? What's the answer? So for first one, I have to think, what is the power to the 10 that give me 1000? What is the power to the 10? Like I'm looking for x such that they give me thousands. Like that, exactly. You're thinking like that. So I'm looking for x, for the value x. What is x, like the exponent of the number 10 they give me thousands? Is 3, exactly. Exactly, 3. So again, you're thinking what is the exponent or what is the power of this space that give me 1000 is 3. Again, for the second one, I'm thinking like that. What is the power for the 2? They give me 32. Like I'm looking for the value x that give me of the base 2 that give me 32 is 5. Perfect, thank you. And for the last one, what is the value for 16 to the power x? They give me 4. What is the value for x here such that 16 to this x they give me 4? I know the square root of 16 is 4, and the 16 square root of 16 is 16 to the power 1/2, positive 1/2. So the answer is 1/2, positive. Okay. Is it clear for all? Okay, thank you so much. So I will see you next Thursday. Let me stop recording for this one.